Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Aaron Newcomb joins me. We're going to be talking about Weaviate, which is a GraphQL processor. You're going to relate data. Very cool. You're not going to want to miss this, so stay tuned. FLOSS Weekly is brought to you from LastPass Studios. Securing every access point in your company doesn't have to be a challenge. LastPass unifies access and authentication to make securing your employees simple and secure. Check out lastpass.com/twit to learn more.
Podcasts you love.
From people you trust.
This is Twit.
This is FLOSS Weekly with Randal Schwartz and Aaron Newcomb. Episode 565, recorded February 5th, 2020. Weaviate. This episode of FLOSS Weekly is brought to you by Melissa. Bad data happens to good companies. That's why 10,000 businesses count on Melissa for clean, reliable address data. Get started today with 25,000 records cleaned for free. That's a $75 value at melissa.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, the little projects you may have heard of and be using every day, projects you might not have heard of at all and might want to download and play with right after the show. I bet today is going to be one of those. Joining me once again is my lovely and talented co-host, Aaron Newcomb. Aaron, welcome back to the show.
Hey, Randal, good to see you. I was not here last week, by the way.
Yeah, right. We figured that out after a while. I don't know why my notes said that you were here last week, but it's because you were here 2 weeks ago and I just didn't update my notes. I am once again in Beaverton, Oregon, my home. I'll be here for another couple weeks. And then I'm going to be in Tijuana for 3 weeks in a row. So we'll be doing some shows from down there. But in the meanwhile, and you look like you're in your wife's makerspace.
Yeah, my wife's makerspace. Yeah, no, this is my messy study. I still haven't got the view. I need to get the reverse angle here so that you can see the layout. I've never done it, but I do have a project to talk about real quick. This is something I've been working on that people might be or might not be interested in. Depends on how much you love. I've got a broken wire here. It depends on how much you love Apple II. If you're an Apple II fan, this is a prototype that I'm working on, which will take it plugs into the joystick port if you've got an Apple IIe or an Apple IIc or GS, I guess, and so on and so on. It'll plug into the joystick port, and then you can plug in a modern USB joystick to play games on it, because a lot of the old joysticks are kind of falling apart and have issues. And I've been able to restore several of them, but they just need constant fiddling. So I thought, you know what would be easy is just to take a modern joystick, plug it into the joystick port. But to do that, there's some crazy things you got to kind of figure out. So that's my latest project. It's really exciting.
You know, joysticks, I just haven't heard of those for decades, actually. So I remember having my Atari, and I had the joysticks there, and the joysticks would eventually wear out and cause issues because I couldn't go up or anything anymore. So it was kind of silly,
and that happens a lot. You can repair those joysticks pretty easy. Commodore and Atari are pretty easy to repair because they use a simple short or pulling a pin to ground to register a direction or a key press. Right. Atari is a little different. Woz did some crazy timing things with the joystick circuits where he's measuring how fast it charges a capacitor, but that means you have to do all kinds of wonky things when you want to emulate it. So that's what I'm up against right now, but I'm making good progress.
Cool. Well, so we have an interesting project on today, which I haven't read up too much on, just a quick skim of their website. So I am completely, what would you say, uninformed. So this will be fun. But it's good because it's a good proxy for the people at home, because people at home are uninformed as well. So it's good. But today we have Bob Van Lullabot, who's going to be talking to us about Weaviate, which is a GraphQL. And I kind of know what that's about. It's a Restful API-based knowledge graph with a built-in semantic model called the contextuary. So if you're playing Buzzword Bingo at home, get out your cards. I think this is going to be a lot of good buzzwords today. But GraphQL in general is basically a way of analyzing data that is about how the data is related. So it's basically you're building up. It's not like a relational database where you have tables of things. It's more like a graph of things. So this is going to be fun, and I'm sure we're going to have Bob talk to us about how this all works together. What do you know about this so far?
Basically nothing as well. So this will be, we're double blind here. I mean, obviously I know a little bit about GraphQL and the technology behind it. It is buzzword bingo today. I mean, if you look at, we'll have to ask Bob about this, but if you look at the introduction website, it says Weaviate is an open source GraphQL and Restful API enabled smart graph based on a word vector storage mechanism called contextionary, as you said. And like, so literally there are more buzzwords in there than other words, but it is
that'd be the entire first column, accurate. I think. The entire first column on a bingo graph. Yes.
Yeah. So, but I assume it's very descriptive, and it explains exactly what it is. So we'll have to ask him when we do the description to break down all those pieces and how they play together.
Well, we're going to bring Bob on in a minute, but before we do that, I do have an important message, because this episode of FLOSS Weekly is brought to you by the leader in address verification, Melissa. Every address is covered from Adelaide, Australia to Zipacada, Colombia, and everywhere in between. We all know there's nothing good about bad data. It costs money, hurts sales, and decreases customer satisfaction. If bad addresses, duplicate records, and bouncing emails are hurting your business, isn't it time to come clean with Melissa? Delta Faucet, Z1 Motorsports, and Car2Go use Melissa. You should too. Delta Faucet was able to improve their call center processes with global address autocompletion. Melissa was able to reduce the fraudulent e-commerce transactions for Z1 Motorsports by 90%. Melissa provides a full spectrum of data quality protection for your customer data, verify postal addresses, mobile numbers, and email addresses. Update the addresses of customers that have moved and eliminate duplicate records. Gain additional customer insight into your data with Melissa's analytics. Easily build address verification and customer data validation into your custom application using Melissa's APIs, CRM cloud connectors, and e-commerce plugins, or upload your customer file for a quick data cleanse. Melissa is serious about securely managing your data. They continually undergo independent security audits to reinforce their commitment to data security, privacy, and compliance requirements. SOC 2, HIPAA, and GDPR compliant. Mailers spend about $20 billion annually in undeliverable mail. Don't lose customers or cash. Make every address count. Bad data happens to good companies. That's why 10,000 organizations worldwide trust Melissa to get their customer data clean and accurate. Get started today with 25,000 records cleaned for free. That's a $75 value at melissa.com/twit. That's melissa.com/TWIT. Or call 1-800-MELISSA to find out more. And we thank Melissa for their sponsorship of FLOSS Weekly. Let's go ahead and bring Bob on. Bob, welcome to the show.
Well, thanks for having me.
And where are you speaking to us from?
I'm speaking to you from Amsterdam in the Netherlands.
Amsterdam. I was just there about 6 months ago. Yeah, so got to walk around all the canals and stuff and have a good time. I think I was on one of the many canals having lunch, so that was a while back. I have a couple of friends that live near there, so they were basically giving me a tour of the area, so it was a lot of fun. Anyway, so give us the 30,000-foot view. Why would I reach for this project? Why would I reach for semi-technology? What's the name of this thing? Weaviate. Why would I reach for Weaviate? What am I solving with this?
Yeah, so it's nice to start indeed with the problem. So to give you a little bit of background, in my whole career I've been working as a freelance software engineer. Mm-hmm. And the problem that you might also recognize is every time that we were working with data or that we work with data, the problem is that we lose the context in the data when we store it. Right. So, for example, I always like to take the example of actors. So if you would have, for example, Brad Pitt, and you would have the entity of Brad Pitt in your data set. But if you would store that again, then you have two entities of Brad Pitt in your data set, but they mean the same thing. And a lot of problems are coming from this, right? That we don't have context in the data sets that we have. So that was the problem, and I was looking for a way to solve that problem. And a few years ago, when the whole machine learning boom started happening, one of the things that was happening was something called word embeddings and word factorization. And what word embeddings do is that they relate words together in a space. And the nice thing about that is that words that have similar meanings are closely related to each other. So, for example, if you have the word apple, it might be closely related to fruit, but also to iPhone or company.
Right.
And the idea that I got a few years back was, what if we would calculate new vector positions on data objects? So now if you, for example, have a complete data object that we say, hey, we have a company with the name Apple. And we calculate a new position based on that. And we store that data object not in a traditional row or table structure, not in a traditional graph structure, but in that space. Would it then be possible to actually index our data and search through our data in a semantic way? So now if I have a database, a Weaviate that has, for example, a company with the name Apple, and I would query for show me everything you know related to the iPhone, it would say, well, I have a company with the name Apple. And that turns out to work. So the reason to reach out to Weaviate is that you now can create new products, new solutions, think about search engines, automatic classification projects. You can just create new things that you couldn't do before. So, for example, let me give you a practical example. Let's say that you want to build a tool that indexes photos, right? So you have a photo of an elephant, and you store it in Weaviate. Back in the days, you had to store metadata about that photo. So you would say elephant, animal, savanna, and those kind of things. Because if you then would search through the database, then you needed, of course, have a match on the keywords.
Right.
With Weaviate, you don't have to do that anymore. So if you store a photo and you say, this is a photo of an elephant, and you would now search for show me everything that you know related to something with a trunk, then it would show up that elephant. Or you show me animals that live on a savanna. Then it would make those relations automatically. So it is a data solution or database, if you will, with a built-in machine learning model. And that is what we call the contextionary. So it's instead of dictionary, it's a contextionary. So it's a space in which we store the data rather than in a traditional database or graph.
Well,
so that's the reason why.
This is the kind of thing that doesn't Facebook publish something like this?
Yes, absolutely. So, for example, what we use that comes from Stanford, but researchers within Facebook and within Google, they're doing a lot of scientific publications. Yeah. What we've done is that we've taken those scientific publications and we said, like, can we engineer an actual solution around that? And that's what we've done. So this is like not just a piece of machine learning anymore. It's really a solution. It's really a product that you can use.
What kind of hardware do you have to run this on?
So everything comes containerized, and it depends, of course, a little bit like where you want to scale. But if you just want to run a simple setup, I'm run it on a MacBook, and my MacBook has I think 2 CPUs or something, and 8 gigs of memory, something like that. And it works perfectly well on that. Of course, it doesn't scale to millions of nodes, but it starts very simple. So you can, if you use, for example, a public cloud provider and you want to use the open source software, you can just start with a $20 a month machine and start playing around with it.
Sure. And what's the adoption been like?
Yeah, so that's interesting. So we make a distinction in 3 ways of the adoption. So first is the actual download. So we offer it through a Docker Hub. So we now have about 16K in downloads there.
Nice.
Then secondly, we have the usage on for example, GitHub and those kind of things. There we have now 200. What is it again? 224 something, I believe, like Stargazer. So that's not very big yet. And then, of course, we have customers because we build a business model around our open source software. And we now have 6 enterprise customers. And to place that a little bit in context, the company itself is now 7 months old.
So what do the enterprise customers get that I don't get just from downloading it?
Yeah, that's a great question. So the software is always the same. So an open source user gets exactly the same software as an enterprise user gets.
Nice.
The difference sits in all services around it. So, for example, open source comes with an open source license, which, as we know, basically says if something goes wrong, it's your problem.
Yeah.
So what we do with the enterprise software is that we take that license away and replace it with an enterprise license. And then we have a variety of other services like support and whatever you can think of around the software. But I'm a strong believer in offering startups or hobbyists or whoever the same software as the enterprise users get. So software is the same, everything that surrounds the ecosystem around it, if you will, that's paid for.
That's admirable because, if we had Simon Phipps on today, he would be like upset if you had a different version of the software for the commercial customers because he really hates open core. So I have to channel him occasionally when he's not here. But no, so how did you get involved with this, though? What attracted you to this kind of software?
Yeah, so that's a good question, actually. I remember that I was on a call years ago, and somebody showed me what you could do with these vector representations of words. And there's like a famous example, if you will, if you're in that realm, and that is that you could do a calculation where you took the word king, and then you took the vector position of the word man. And then if you subtracted them and you would go to the other vector position, it would say queen. Right. And I remember when I saw that for the first time, and I was like, oh, I don't know if I can curse on the show, but I was like, holy cow. I was like, this is amazing.
You can say that.
Yeah. Okay. Yeah. So I don't know. So yeah, in Holland we have different standards, I guess. But and I saw that, and then I was invited in San Francisco to see a few launches for new products on Google Cloud. And yeah, that's exactly it. What I saw on the screen, that's exactly the example. Yeah, that's it. Yeah, that's it. Yeah, and I was in San Francisco there was a launch of Google Cloud, and I knew that companies like Google were doing research in this domain because, of course, that's what they publish about. So I asked them, are you going to build a product on Google Cloud or something that will offer these kind of services that people can now store that data in a contextual way like you might do on something like Google Search? And then this person told me no. And then I was like, that's my opportunity. I'm just going to try it. And I opened the GitHub repo on the airport in San Francisco 2.5 years ago. And, now I'm here.
Cool. I've been told by the Andromedan in the chat room that your license looks not like one of the OSI approved licenses. Is this derived from? It's sort of like the 3-clause BSD license. Is that close?
Yes. I love another great question. So let me explain why our license is the way that our license is. Yeah. So first we started off with the BSD 3 license. Yes. But then there was a New Yorker article, a New York Times article that wrote how Amazon was, depends on your viewpoint, but I would be of the viewpoint of misusing software like Elasticsearch and MongoDB because they were misusing their licenses. Okay. So you can, if you Google that for Amazon and Elasticsearch, you will find the New York Times article. Yeah. And so I just asked a lawyer. I said, I want to have the benefits of the BSD3 license, but I don't want to have this stuff happen to our business. So this lawyer suggested a few amendments to our license, so that he said like, well, now you still have people can reap the fruits of having the open source license, but you're also safe against those kind of situations. So that's why we have a BSD 3-ish kind of license.
I love how you said you actually asked Google, are you doing this? And then that's how you determined if you were going to do it. It's like, well, if Google's going to do it, never mind. But if they're not going to do it, I'll take it on. I love that. I mean, there must be other people doing this, though, right? Are there other projects or commercial projects that are in this space?
I have to be careful with my answer here, but it's difficult to find them. So I'm just not gonna say I'm not gonna say no, because that's too dangerous, because probably somebody has a similar idea. But it's difficult to find them, because of course when we and this has to do with the business side of what we do, is we of course try to understand what the landscape looks like and what others are doing, and we know that people are researching what they can do with these vector spaces and these models that come out, but like a full-fledged product, I haven't been able to find it. And if it's around, then sorry about that, but I just simply haven't seen it yet.
Interesting. And what's the I was looking at the website, which is in your lower third there. Is it Semi Technologies?
Yeah, so it's short for Semantic Machine Insights.
Okay. And is this just one project of many for the company? Is this, and you founded this company, correct? This is the company you founded.
Yeah, well, I'm one of the three co-founders, but that's correct. Yeah.
I mean, I see Weaviate, and then I see Knowledge Networks.
Yes. So the Knowledge Network. Yes. So that's something we're currently working on, and that has to do with another problem. And what you see often now in discussions is that people talk a lot about linked data and the beautiful things that linked data can bring. There's one problem, though, in linked data, and the problem is that we need to agree upon an ontology. So, and a simple example there to think about it, let's say that you would go into an organization, and first you go to the sales department, and you would say, okay, how would you define a customer? And then you create your data model on about how they define a customer, and then you go to a business unit, and you say like, okay, how do you define a customer? And what you will quickly learn is that people have a hard time agreeing on how to call stuff. That's also that one could argue that's also one of the reasons why it's still difficult to get proper linked data set up. And with Weaviate, we came to the conclusion, because it has this semantic model, that if you, for example, would decide to store a business with the identifier Apple Incorporated, and I would say, no, it's a company with the name Apple, then two Weaviates could actually together determine, well, it's probably the same thing. So now we can also make relations between multiple Weaviates who run in multiple data centers, and we do not have to agree on the data model that is in those Weaviates.
Interesting. This seems to cross over also into machine learning and AI in a certain sense, in that it could be a source of information for those systems. Is that true, or am I stretching here?
No, not at all. And so the what we call the contextuary is a machine learning model, which we train on all the usual suspects, so Wikipedia, Wiktionary, scientific articles, those kind of things. And we make that available also open source, so people don't have to do their training themselves. They just all get it out of the box. But if you jump now into the AI realm, if you will, and if you use that, so here we go on the buzzword bingo. But if you use the terminology AI, then there's this very interesting interview online with what's his name again? Mark Andreessen from Andreessen Horowitz, where he asks the question: is AI, in the broad sense of the word, is it a feature or is it a architecture? And he says, like, if it's an architecture, it's very interesting, because then we can build new applications on top of it. But if it's a feature, it's just an add-on. And we would argue that you can use Weaviate in your Well, AI-based architecture, because it's a completely different way of indexing your data and structuring your data. So these ontology definitions, agreement on certain schema items, et cetera, you don't have to do that anymore. So you can now build new products, new solutions in your architecture when you use Weaviate as a data store.
It seems like it's a natural fit, and it's the problem that a lot of AI models have, or the challenge that they have to overcome is the context challenge, right? It's what prohibits you in a lot of cases from getting from one side of the fence to the other side of the fence, is they don't understand apple versus apple, right? They don't get it. And so you have to provide them with some sort of mechanism to figure out, oh, in this context, when I say apple, I really mean the fruit and not the company, or vice versa. And it seems like you've done that very well. I did mention at the opening, you've got a lot of, well, we both mentioned there's a lot of buzzwords here. Not really buzzwords, just technology terms that would be helpful to understand. So,
Sure.
So we have open source. We've kind of got that covered. We talked about the license. GraphQL, which I think we've done other shows on, if I'm not mistaken. Randal can correct me if I'm wrong, but we go back and look that up. Restful API, that one should be obvious to anyone listening. Here, it's a way to interact with the product, the system. And then we're on, and then it says it's a smart graph based on a word vector storage mechanism. So can we talk about the smart graph? We've talked about it a little bit already, and then also the word vector storage mechanism. What do you mean by those two things?
Yeah. So let's first look at smart graph. So to start with the last word, so a graph, we store all data with all the relations that it has. So for example, I have a company which is in a city, and a city is in a country. That's also the reason why we adopted GraphQL, because if I may quickly say something short about the GraphQL, the reason why we did that is because we believe that a lot of existing graph systems use one could argue complex query languages, like, for example, Sparkle. So if you're like a junior developer or somebody who just wants to start working with graphs, it's difficult to understand how that works. And GraphQL is very, you can use it. It's easy to use. It's easy to get started. So that's for the word graph. So everything that we do is stored in relations, because we believe that everything is a relation. Every data set, well, not every data set, but the majority of data sets can be expressed in the relations that things have to each other. So that's for the graph part. The smart part has to do with that built-in machine learning model. So because we often see that the word smart is applied if it somehow contains something machine learning based. So when we say smart graph, we mean it's a graph with a built-in machine learning model. Mm-hmm. Like others might use smart database or something like that.
Okay.
The rest of the sentence, that's actually what we talked about. That is the vector, the storage mechanism, which we call the contextionary. And sometimes if people haven't seen that, it's sometimes difficult to envision, to imagine, like, what does that actually mean? And I always like to give a metaphor for a vector storage mechanism, and that's this. If you would go to a supermarket and you have a shopping list, and the shopping list says, well, I need to have bananas, bread, apples, and washing powder. And you go into a store, let's say you go in the US, you would go into the Whole Foods, for example. And now you find somewhere, you find an apple. So you're in a space, which is the Whole Foods, and you find an apple. Then you know that the banana will be closer by than the bread. But you also know that the washing powder will be even further away than the bread. And if you move towards the bread, you know that on one hand you have the fruit where the apples and the bananas are, and on the other side you would have the washing powder. This is how that vector space is structured and organized. It's not in 3 dimensions. It has a little bit of more dimensions, but that is how that data is organized. So every time when you add a data object, so let's say I would say, like, I have a podcast with the name FLOSS Weekly, and it tries to determine what do those things mean. It creates a data object and it places that in the space. Like if you would now add to the supermarket a bag of chips, you would logically place that somewhere in that space. And that is what the vector space looks like. And because we engineered all these kinds of things around it, we made it into a service, and there's all these bells and whistles around it. And that's what we call the contextionary. So it's an easy way to refer to it. So the Weaviate Smart Graph comes with a contextionary. And what is a contextionary based on? Well, a language. So you have a contextionary in English, contextionary in Dutch, et cetera, et cetera.
And did you have to build your own machine learning algorithms, or are you using some of the standard models?
Yeah, so we adopted a model called GLAV. That's what we adopted. And everything around, so what GLAV outputs is just a text file that it says like, well, I have the word podcast, and it is the vector representation around it. So what we did is we optimized the model for training. We've engineered a whole service around it. We created a nearest neighbor tree around it, because one of the problems is that the amazing work that the people are doing in the scientific world is often not optimized from an engineering perspective. So if we now want to use it for thousands of millions of data entries, it's sometimes difficult to do that and use it. So the whole thing around it, that is something we completely engineered. And so that's the model we use. We use the GLAV model for training, and then we optimized it, and everything around it is something we created ourselves.
Cool. What technologies did you build this on? I'm sure you didn't start from scratch on all this. You said you're leveraging, was it Goth? Sorry, it wasn't.
No, not Goth. No, it's glove. So like the thing that you put on your hand, right? When it's cold outside, a glove. Yeah. And with a capital V. And if I may say something about this is something for the people on the listening who might be knowledgeable about these kind of things.
Sure.
We see that there are more new models around. So first we got something called Word2Vec, then we got Glove, and now we have things that are called BERT and Elmo. And they are called, so BERT and Elmo are called state of the art, because what they do is that they have multiple vector representations for a single word, which helps you, for example, with question answering. But if we take off our engineering hat our data science hat, and we put on our engineering hat, then we see that models like GLAV are very helpful and make engineers like us very happy, because this is relatively easy to index. So now we can also make it very fast. And we just calculate real-time new vector positions based on those individual identifiers that we have. So if somebody is curious, like, why are you using that model? That's the answer. That's why we do that. So if there would be a new model that maybe one of those big companies or big university releases in the near future that has, again, single representations of words and concepts, then we would, probably go to that one.
And is this the kind of thing I could feed all of Wikipedia to, and it would be smarter than me?
Randal, I don't know if we can build a system that's smarter than you, but
that would be easy. Don't worry. My knowledge only goes so far.
Yeah. No. So, but yes, we feed it the complete Wikipedia. We feed it the complete Wiktionary. We feed it a lot. And what is currently, what is the how do we distinguish in the data sets is that we currently do that per language. So we do it for example, in English, in Dutch. So, and then we take those data sets. So the training that's happening is we're using a huge machine in the cloud that is like, steaming and pumping for like 2 days in a row. Yeah. And then it just outputs this little tiny package, which is, the contextionary.
Well, it's obviously feed all of the Wikipedia. My name's in there somewhere, so it's going to be interesting to see if you ask it now. What do you know about Randal? What do you know about Randal? Because it'll be in there somewhere. So what's the most unusual observations that have been made by having this much data and being able to analyze all of it?
Do you mean people who use the software or when we train it?
I think I mean like both of those, but okay. Whatever you think is an easier question to answer.
Yeah, so let me say about the latter one. This is like not to make this point too political, but it was something that I was surprised about. So when we looked at the model, I was surprised how much in all those data sets that we have that seem very objective, how much things we have related to he. So that was just something that I was surprised about. So that we see that the model trains a lot of like he does, he moves, he, etc., and there's not a lot of she in there. That was something I was just surprised about. And I find these things very important because we offer these kind of models to the outside world to use. So we need to see if that it has an impact. So that is we take that very serious. There's actually somebody in my team who takes care of the whole UX, which also means the models that we train. So that's the first answer. And secondly, what we see is that on the most abstract level, people use it mostly for three things. Okay. So one is semantic search. Mm-hmm. Imagine that you have a web shop, right? So you have the FLOSS weekly web shop, and you might have numbers that people they look for something in the shop, and there might be a cutoff point. So like 80% of people are able to find what they need, but 20% aren't. And right. You just lose those 20% because they type something in and they can't find it. Right. Why can't they find it? Because they're probably using the wrong keywords, and the keywords are not in the database of the e-commerce store. Well, if you use Weaviate, you can actually say, like, for example, if you would have like something related to food and you would type in Pepsi, then it understands, air quotes, it understands, hey, somebody is looking for the drink Pepsi, but maybe also for other forms of cola. So if you then keep scrolling down, you first find Pepsi, but then you might find other brands of cola, for example, or Coke. And so we can increase that number from 80% to X more. So a lot of semantic search applications, that's one. On all kinds of data sets, whatever you can think of, if it's textual data, you can search through it. That's one. The second thing is that we have a feature in Weaviate that does automatic classification. Mm-hmm. So, for example, let's say that I would have a node in my graph which says type company, and I would say I have one which is again a business with the name Apple. Yeah. Then it can automatically make those relations and saying like, hey, I can actually relate these automatically because they are companies. Apple is a company. So that what we also have, and that is something that we have recently, and that's something that I'm very proud of. That is, and I didn't build it, but I'm proud of the. Should do a shout out to the great team that we have, but the people build it, and that is something we call entity merging. So we have an example data set where we have all kinds of news publications. Sure. And we have the New York Times in there 3 times. So you have New York Times Company, and the International New York Times. Mm-hmm. The problem is that if you now say like, how many publications do you have? The system says like, well, I have 16. But that's not true. It has 13, but the New York Times is in there 3 times. Ah. So one of the things that we can do is something that we call entity merging. And that automatically not only says like, hey, you don't have 16 publications, but 13, and these 3 are probably the same thing, referring to the New York Times. Ah. But it even also merges the graph together, that it understands that the articles from those 3 different entities are from the same news publication. So that, and then the last thing that we have is something which we call knowledge representation, which is a little bit more abstract. But what you often see, especially for developers, if you work on a traditional data set, then the schema in the database is often created for a single use case. Sure. Now, if somebody comes to you and says like, well, can you also do something else with it? Is data set? It's extremely difficult because that's not how the data is structured. And in such a graph structure, it's way easier to just take shift the data 180 degrees and look at it from a different angle and create a new use case around it without restructuring it, without reordering it, etc. So those things we see people using it for a lot.
Cool. Hey, so there are people at your company working on this. How many people are there?
So we're currently with 5.
Okay. And are you getting contributions from outside? Are you getting pull requests for your GitHub account?
The most thing that we get is people asking questions. So that on Stack Overflow and on GitHub. So, hey, that they, for example, say, well, I want to have a context dictionary in my language. Can you create one for me, please? And then we say, of course. So that's nice. So people ask a lot of questions. We see the most feedback we get is actually on documentation. So that's sometimes where people help, because of course no good documentation isn't a good open source product, or even a good software product in general, I think. So that is where we get the most feedback, pull requests and those kind of things. But it's more that people ask questions and create issues to ask for help rather than do the contribution themselves, which we don't mind, which is okay.
And what's the biggest missing? What's still like one of your biggest issues that you want to make sure gets done soon?
That's a great question. Yeah, so I want to have that. I would love to have that. So I know that my team will also be listening to this. So thank you for asking. So that network feature is something that I really would love to see.
Sure.
That's something we would like to have. And we see that we sometimes have some difficulties with abbreviations. Okay. And that is also something that we have some ideas for to improve. So those things I would like to see in the near future. But of course we also we optimize. We have users, so if we get open source questions, if we get from our enterprise users questions, right, we try to optimize the software, make the software better. And that is all, of course, a never-ending, ongoing thing. And that's a little bit besides the software, but I think I would love to make more videos, make the documentation even more interactive, that people the bar is very low for people just to get started with it.
And how often do you ride your bicycle?
So a lot. Yeah, so I don't have a car. I don't even own a car. I do everything on my bicycle. Yeah.
I remember the problem with that was that there was this lanes that were just for the bicycles, and then there was the lanes for the cars, and I didn't realize there were lanes for the bicycles, and I almost got run over a couple times because I was like, "Hey, there's bicycles coming at me." It's pretty funny. Anyway, I think Aaron has a couple more questions here. So, Aaron.
So getting back to the meat of the show here, Randal. So how do you actually implement this? I mean, it seems like there's a lot of moving parts here. How difficult is it to actually get started using the technology? If I wanted to adopt this, what pieces, components would I need in place to get started?
Yeah, so if you want to start developing, you literally have to run 2 commands. One is that you need to download a configurations file, and you have to run Docker Compose up. That's it.
So it's all based on Docker. You don't have to worry about standing up different databases or all this other stuff to get started.
Yes, sir, that's correct. So you don't have to do anything. All comes out of the box. Then we even offer the setup for Kubernetes and the Helm charts. We also offer that out of the box. If you want to build a really big production system. But what we also are doing is that we're launching soon also on places like Google Cloud Marketplace and those kind of things. And then even that is just a click of a button away. So we try to make it as easy as possible. And if people look at our documentation and they click on installation, then they will see that they just have to run 2 commands. So you need to have Docker, and that's basically it.
And then how do you get access to the data? What are the mechanisms, the various mechanisms that you can use to access the data that you want to query?
Yeah, so this is where the RESTful API plays a role. So what we kind of as a rule of thumb, we say Adding data is something that's happening through the RESTful API. Querying data is something that you do through the GraphQL API. We also created a graphical user interface, which we call the Playground, which is also open source. It's now in beta, but you can also find it on playground.semi.technology, where you can just fill in the URL of your local Weaviate. So there's a visual engine that you can visualize what's in your data set. But everything is happening to the APIs. It's completely API based.
Yeah, I was going to ask about the front end. Like, how do you visualize this? How do you query it beyond, running a command line something? I mean, are there tools already in place if people have their own preferred way of visualizing this data or accessing the data? Is there a front end that people can use?
Yeah, so the front end is what we call the playground, just the Weaviate playground. What we see the big difference that we see in more the open source users, so for example, startups or hobbyists and those kind of people, they really use Weaviate as an engine. So then you have Weaviate, the APIs come out of that, and people integrate it in an app or in a website or whatever. If you look at the enterprise customers, we see a lot of integrations with these big juggernauts like the SAPs of this world, Salesforce, etc. That people actually take data out, that they want Weaviate to solve a problem, and then Weaviate has to push it back, which is very interesting. So that's how we see that it's being used. But we also have big users who. One of our customers who use the enterprise version, they created an app, and that app is being used by teams. It's a very big company, so there are thousands of people using that app, and it's just the data that the app ingests comes from a Weaviate.
Yeah, that's interesting. I was thinking something like a Salesforce, but then also maybe even something like a Tableau or some other where you want to get that contextual information along with your data sets. It might be really interesting. So it's great that you provide an easy mechanism for people to do that. What about, I don't want to create any competition here, but working for a SaaS company, you mentioned that you can get access to this through, I think you said GCP and maybe other cloud vendors where it's easy to get started with it. But what about offering it as a SaaS service itself, where I don't have to install anything or do anything? I just, log in and set up a couple of things, and you're running everything in the background.
Yeah, we have that. We call that the Weaviate cluster service. So if people want to use the as a product, as a SaaS product, they can go to our website, and we have a variety of options that they can choose from. So the offering that we have is basically threefolded. Number one is the complete open source offering, which again is the exact same software as in the other offerings. Then we have the SaaS offering, which we call the Weaviate cluster service, which starts from $49 a month and then goes up. And then we have the enterprise version, which also comes with dedicated support, and that you even can run it on-prem if you want to. So that's the range of what we're offering.
Why the name Weaviate?
That's a funny that I can tell you, but it's so at that same I can tell it. I just gonna tell it anyway. Okay. So at that same conference where I was in San Francisco, Google did offer a new service which was focusing on the Internet of Things, but I had this idea that we will be talking about data objects as things anyway, because that's what we do in the semantic web as well. So, for example, this coffee cup, we call it a thing. So, and they called that service back then, they called it Weave. And it doesn't exist anymore. It's gone. But I thought I think this is so unfortunate, because I knew that they wouldn't build stuff around it. So then I thought maybe we can do better, and that is where the idea of Weaviate. So it's tongue-in-cheek. It's tongue-in-cheek to that product that doesn't exist anymore, which was called Weave. So you had Google Weave, and then we had Weaviate, and now we only have Weaviate.
So it's kind of a tip of the hat to Google's product that no longer exists.
Oh man, these products, I'm not here to pitch for them, but they have some amazing engineers. They know how to build products.
Sure.
Holy cow, it's just very impressive. I mean, for people like us, this is important. We look a lot, to these companies, but also read blog articles, not only from an engineering perspective, but also I remember that 2 or 3 years back when they launched their open source strategy during the keynote in San Francisco. That's impressive. I learned from that, right? So we tried to, even although we're small, I tried to model the business around what I learned from how these companies operate. So they're amazingly impressive.
Well, I'm betting a lot of my future on Dart and Flutter, so I'm hoping that they don't abandon that anytime soon. But it sounds like they're not going to. Those are pretty embedded in what they're doing there. I do have a question from the chat room, which is, when are you going to incorporate blockchain into this?
That's a joke.
It's a joke question.
Yeah. So I think never. I always like to say, it's like decentralized as not in blockchain. Yeah. I always say think Napster, not blockchain.
It's become the joke question for every show now. So we always have to ask about blockchain, just because we actually had a couple shows where that was important, and then we had a bunch of shows where it wasn't important, and so we just kept asking about it anyway. We're almost out of time. Is there anything we didn't ask that you want to make sure our audience is aware of before we have to let you go?
Well, I just want to invite people to use it and to share their thoughts and what they think and ask questions. It's we would love to to have people use this software and hopefully help them build better solutions or products or even hobby projects, whatever they want to build. So that's what I would like to say, I guess.
Cool. And I hope to get back to Amsterdam again someday soon, because it's a beautiful town. I definitely enjoyed being there. And also it's the home of Booking.com, which is a big Perl shop. So I know a lot of people that work at Booking. So many people work there. Anyway. Sorry, what?
No, I want to say a lot of great open source software comes from Europe.
Yes, indeed, and especially Amsterdam. I mean, it's definitely a haven of wonderful stuff. 2 more questions, or else my audience gets mad at me. What's your favorite text editor?
Yeah, so I knew you were going to ask this because I listened to the podcast. So the answer is embarrassing. So I use Visual Studio Code, which is not that's not the embarrassing part.
That's a good one. I know. I like that one. I'm using that now. Yeah.
But the theme that I'm using is like a kind of neon glow in the dark theme. And when my team sees it, they go like, "You're nuts for using that." So I use a neon themed glow in the dark Visual Studio Code editor.
Well, I like Visual Studio Code because, like I said, I'm now into Dart and Flutter, and I hadn't been into an IDE before that was, strongly typed, that sort of stuff. And now it's perfect for that because I can get code completion and a bunch of other cool things going on, dynamic.
I love
yeah, very cool. And what's your favorite scripting language?
Yeah, so that's also a difficult question. I think I would go for Python, actually.
Okay. Yeah, that's fair.
Hey, good for you.
It happens. I'm sure. Yeah, you just made Aaron happy, but me, it's like if it's not Perl, it's like whatever.
Weaviate is written in Go, by the way, but it's to use it. I like to use Python.
Sure. Well, Bob, it's been wonderful having you on. I'm sure a lot more people are going to play with this now that they've heard about what it can do and download the Docker image and launch it up and hopefully have a good time with that. So thank you, Bob, for coming on the show and talking to us about Weaviate.
Thank you so much for having me. I really enjoyed it.
Very cool. That was Bob, whose name I won't try to mangle. So I'll just say Bob.
Bob von Luijt.
There you go. That. Exactly what he just said. Exactly. And Aaron, what'd you think?
Really cool stuff. I mean, this is kind of the world that more and more of us are living in day to day. At my current company, AppDynamics, we use a lot of this similar technology in the background, but we're monitoring applications and infrastructure. But the problem is that it gets so complex that it's very difficult to find the commonalities and the context, if you will, about what's going on so that you can actually get to root cause. So we're doing a lot of this internally, thanks to the good work that JF Heward and his team from Prospica brought to App Dynamics. But this is a as things get smarter and smarter, you need this type of mechanism to provide context to what's going on. Otherwise, we never actually get smarter. We just get more functional, right? So that's the difference. And so I think this is great technology. I'm glad that it's open source. I think a lot of people will be able to take advantage of this and do some really amazing things. It's nice that you don't have to create this from scratch yourself, because that's the hard part these days, is coming up with these algorithms yourself to do what you want them to do.
We're getting closer and closer to the Star Trek Enterprise computer, where you can just ask it something and it just knows. And I think that's amazing, because I didn't know that I would be in my lifetime able to start hearing about stuff like this. I still thought this was still 30 years out. And so for this to be, starting to be kind of almost the norm rather than the exception, it's starting to be really interesting period of time to be alive. Because if we can start like reading in, as he said, all of Wikipedia, and be able to ask questions about Wikipedia entries, like who is Randal Schwartz, and be able to come up with stuff for that, and to build correlations about that. That's the important thing. It's not just being an idiot savant where this is related to that, but that you're able to then say, and that makes it also related to this, which also makes it related to this. That I think we're getting into a great space in knowledge engineering, which is a huge thing.
Yeah. It's just funny when you were talking about the Star Trek computer and all that. I was thinking it would be really funny. This is anyone that wants to go make a funny YouTube video. I think this would be hilarious. Is to have it set on the Enterprise, but have the computer react the way that Alexa or Google Home reacts today, right? So the guy's in his room, he says, hey, computer, turn down the lights, right? And, all the lights on the whole ship dim, something like that. It would be a funny parody, I think, to realize the technology that we have today. We're getting there, but it's still not very smart. It's certainly not as smart as we'd like it to be sometimes.
Well, and Works makes a good point in the chat room, but we already have that, which is Watson, but it's not just Watson. If you ask Siri questions, if you ask Alexa questions, you can get some amazing responses these days. Mm-hmm. So obviously, they've got these big warehouses full of where Siri actually lives. I think it's on the East Coast somewhere for them, but it's like. But it's amazing now what we're doing with our technology, and then of course, then we're gonna melt down the Earth from global warming. So we're in the last 20 years anyway. But whatever. Right. So anything else before I start wrapping the show?
No, that's it. My head's still spinning about what potential use cases there could be for this technology.
Yeah, I know. It's just amazing. I mean, I may actually have to go start playing with this. Except I say that almost every week. I never get around any time to actually do this stuff. So there we go. So let's talk about who's coming up. Nobody knew since last week, but next week we've got one of my friends, Hillel Koren, is going to be talking about Flutter, what's changed in the last 6 months about that. And he was also on a couple of years ago talking about Invoice Ninja, which is his free-to-use invoice processing software, which is still free to use, which is kind of amazing. I don't know how he makes money on that. It makes up in volume, I guess. Hydra for that is a framework for elegantly configuring complex applications. Fun. Deep Code alerts you about critical vulnerabilities you need to solve in your code. And don't let security bugs go to production. Save time finding and fixing them. Then Linux Beerwanderung, which is basically a pub crawl that's going to be discussing Linux as they go from bar to bar, which is going to be fun. NetData, which is distributed real-time performance and health monitoring for systems and applications. Excess Code, which turns your open source project into a steady revenue stream in all caps. Boy, would that be nice if I could turn my open source projects into a steady revenue stream. And then Agonis, something like that, which hosts, run, and scale dedicated game servers on Kubernetes. That'll be really fun, too. Go to twitch.tv/FLOSS. That's the homepage for this show. You can see there all of our upcoming shows. If there's somebody not on that list that you want to make sure gets on the list soon, make sure to have the project leader or community coordinator email me, Merlin@Stonehenge.com. My address is right there on that page, right in the middle of the page. Unlike the one guy who said, I don't know what your email address is. I go, it's right in the middle of that page, right there. He goes, boy, if I'd been a snake, it would have bit me. That's true. Anyway, so yes, my email address is right there. We have a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. We took a couple of questions from there today. You can follow us at FLOSS Weekly on Twitter. You can follow me at Merlin on Twitter, MERLYN. You can join us at the forum at twit.community. There's a whole thread dedicated just to FLOSS Weekly. So, and as soon as this show gets published, they'll add a new entry for this show. It's pretty fast, actually pretty good. I also would like to read you from the home office. It's time for Twit's annual audience survey. If we want to hear from you, it only takes 5 minutes. Please visit twit.to/survey20, 20 digits, and let us know what you think. There's no sign-up form, and we don't track you. Your feedback helps us make Twit even better. So thank you for your continued support. I'm going to be, I just got accepted as press once again for FLOSS Weekly at Scale, Southern California Linux Expo. It's in Pasadena in about a month, I think it is, and I will be there. So if you see me there, please come up and say hi and say, hey, I listened to FLOSS Weekly or watch FLOSS Weekly, whatever, and that would be really happy for me to find out I have audience members. I do know I have audience members because we hear back from you all the time. And Aaron, what do you have to plug?
So I am actually in the middle of changing jobs. I'm going to be moving over to a company called SysDig, and I'm really excited about that. And part of the reason is because they develop a project, open source project called Falco, which is part of the CNCF. And I just did a quick search on Google. It doesn't look like we've had anybody on to talk about Falco. So we'll have to see if we can make that happen. But it's essentially cloud security. It's open source cloud security, which is a big topic these days. So we'll have to see if we can get that going. But I'm just excited because they do, compared to my current company, AppDynamics, they do a lot more in the open source realm. And they're really interested in expanding the open source community around what they do. And so for me, it's kind of a nice thing to be. It's always nice when you're involved with a company that's big on open source. And so I'm really excited about that change coming up in a few weeks.
Cool. And Falco was the guy that did One Night in Bangkok, right?
Yeah, I think so.
So now
I hadn't made that. I don't think there's a connection there, but
you won't be able to get that out of your head now. Every time you're working at the company.
Exactly.
One night in Bangkok. I am like that. But I've sung that at karaoke a few times, so that's kind of one of my favorite songs. So it's kind of a nice thing. Anyway, Aaron, thank you once again for joining me and helping interview Bob. It was a good show. I appreciated it. It sounds like a lot of fun and really bleeding edge technology. So that's always handy. So thank you, Aaron.
Yeah, you bet. Anytime.
All righty. So that was Aaron Newcomb, but no, we've been talking about him the entire show. So I don't know that you just say that. But we'll see you all again next week on FLOSS Weekly.